This chart maps out a startling piece of American history. Since 1950, the U.S. military has experienced 32 catastrophic nuclear accidents. When we filter that data down to the absolute worst-case scenarios, we find 6 specific nuclear weapons that vanished and were never recovered. The military uses a specific chilling term for this kind of event, a broken arrow. It's the official designation for an unexpected incident involving the accidental launch, firing, detonation, or theft, or loss of a nuclear weapon. Containing a broken arrow requires a massive, coordinated response. In 1980, the Department of Defense staged a joint exercise in the Nevada desert called NUACS to test this exact scenario. The drill simulated a C-141 cargo plane crashing with several nuclear weapons on board. Over the course of the week-long drill, some 400 personnel descended on the site. They had to establish secure contamination control lines, track radiation clouds, and recover simulated casualties, and manage the inevitable flood of panicked phone calls from the press and local civilians. The government spends millions on these exhaustive, highly choreographed simulations because it accepts a grim reality. In systems this complex, catastrophic failure is eventually a mathematical certainty. This immense logistical effort is built on the hard lessons of history. The military prepares for the unthinkable because it has already lived through it. In the early 1950s, the atomic arsenal was relatively small, and the protocol for keeping those weapons safe during transit relied on physical distance. The radioactive plutonium core was kept entirely separate from the bomb's conventional explosives, making a full nuclear detonation during a transport flight physically impossible. That safety measure was put to the test on February 13, 1950.
A B-36 Peacemaker bomber took off from Alaska, running a simulated strike mission towards San Francisco to mimic a bombing run on a Soviet city. High over British Columbia, ice clogged the bomber's air intakes. 3 engines caught fire and had to be shut down. Losing altitude rapidly, the crew followed protocol. They jettisoned their payload, a 5-ton Mark IV atomic bomb, into the Pacific Ocean, detonating its conventional explosives in midair before bailing out. Rather than admit they had dropped a nuclear weapon, the military initiated a total media blackout. The crash site remained a secret until 4 years later, when an Air Force demolition team secretly hiked up the Canadian mountainside to blow the classified wreckage to pieces. Keeping the core physically separated from the bomb and burying the truth in the remote wilderness were effective strategies, but they relied on the military having the luxury of time and isolation. By the late 1950s, Soviet missile capabilities had advanced, shrinking America's warning time from hours down to minutes. To guarantee an immediate counterstrike, the Strategic Air Command initiated Airborne Alert. Bombers were kept in the sky 24 hours a day, 7 days a week, carrying fully assembled live nuclear weapons. On March 11, 1958, a B-47 Stratojet was flying over rural South Carolina when a warning light flickered in the cockpit. The bombardier climbed into the bomb bay to check the locking pen holding their payload in place. He lost his balance, grabbed the emergency release cable to steady himself, and accidentally dropped a 3.5-ton nuclear bomb straight through the bay doors. The bomb plummeted toward the small community of Mars Bluff. When it hit the ground, the thousands of pounds of conventional explosives packed inside the casing detonated. Miraculously, the nuclear core did not ignite. Even without a nuclear yield, the conventional blast leveled a family's home, injured 6 people, and carved a 30-foot crater into the earth. The military projected an image of absolute precision and control over its arsenal. But the crater in Mars Bluff proved that routine Cold War deterrence was actively placing American civilians directly in the crosshairs. When a live weapon hits the ground without detonating, it triggers the most perilous phase of a broken arrow response. Explosive ordnance disposal teams are sent in to perform what's known as a render-safe procedure, manually disarming a highly unstable nuclear device. In January 1961, that protocol faced its ultimate test. A B-52 bomber suffered a massive fuel leak and broke apart in midair over North Carolina. As the fuselage tore open, 2 live multi-megaton atomic bombs fell from the sky. When the recovery helicopter arrived, the search team found the first weapon tangled in a tree. Its parachute had deployed properly, and the bomb was resting safely above the ground. The second bomb was a different story. Its parachute failed, causing it to hit a muddy field at the speed of sound. The ordnance team dug 20 feet down into the earth to reach the crumpled weapon. When they finally located the arm safe switch, they froze. The dial was physically flipped to the arm position. A 3.8 megaton detonation would instantly vaporize everything within a 17-mile diameter. That single switch prevented a nuclear holocaust on the eastern seaboard. The crew extracted the primary core, but abandoned the rest. Today, the highly radioactive remainder remains entombed 200 feet beneath North Carolina farmland. The disaster in Goldsboro was contained, but not because of rigorous military protocol or flawless engineering. The prevention of a domestic nuclear strike came down to the arbitrary failure of one fragile switch. The orderly, textbook success of simulations like the 1980 NUAX drill stands in stark contrast to history. In the field, broken arrows are chaotic, unpredictable, and often edge dangerously close to the apocalyptic. Today, the U.S. nuclear arsenal is a fraction of its 1966 peak, yet incidents still happen. In 2007, a cascading series of security failures allowed 6 live nuclear warheads to be loaded onto a B-52 and flown across the country, completely unmonitored for 36 hours. It was a terrifying reminder that human error remains a constant threat. We have built highly complex engineering systems and drafted volumes of emergency protocols to contain a nuclear disaster. But looking back at the last 70 years, the ultimate failsafe protecting humanity from a broken arrow has often just been sheer uncomfortable luck.